As we first look at our next equation to solve, 1/2 t plus 1/3 equals 1/6 t minus 1/3, a few things should definitely stand out. 1, there are fractions throughout this equation, and 2, some of these fractions have different denominators. The approach that we want to use is to take this equation and, as a first step, clear out the fractions. To do this, the first thing we need to do is figure out what is the lowest common denominator of all of the fractions through the entire equation. When I look at the left side of the equation, I see the lowest common denominator is 6, because that is the smallest number that both 2 and 3 divide into. On the right side of the equation, the denominators of 6 and 3 also have a common denominator of 6. So once I've determined that the lowest common denominator, the LCD for the entire equation, is 6, I'm going to choose to multiply both sides of the equation by that common denominator. 6/1 times the left side, and separately 6/1 times the right side. Again, we're making use of the multiplication property of equality in a slightly different way than we typically do when we solve equations. Our next step is to distribute that 6/1 to both sides of the equation. Because there are many different fractions throughout this equation, I tend to write this step out. 6/1 times 1/2 t plus 6/1 times 1/3 equals 6/1 times 1/6 t minus 6/1 times 1/3. If you're more comfortable doing this multiplication in your head, that is fine, but the more complicated it becomes, the more I would encourage students to write this out. We now need to go ahead and simplify each of these new products. 6/1 times 1/2t gives me 6/2t, which is the same thing as 3t. 6/1 times 1/3 is really 6/3, which reduces down to 2. 6/1 times 1/6 is 6/6, so I get 1t. And 6/1 times 1/3 is 6/3, which is 2. So by multiplying both sides of the equation by 6, I turned an equation 1/2 t plus 1/3 equals 1/6 t minus 1/3 into the equation 3t plus 2 equals t minus 2. I personally would rather choose to solve an equation that does not have fractions in it over an equation that does. It's not that I can't solve an equation with fractions, it's just that it is more complicated. To finish solving the equation 3t plus 2 equals t minus 2, I will again isolate the variable terms by moving the variable to the left side of the equation. Since there is a 1t on the right side, I will subtract t from both sides. And simplifying, 3t plus 2 minus t on the left side leaves me with 2t plus 2. On the right side, t minus 2 minus t leaves me with a negative 2. Now turning my attention to the left side of the equation, I have 2t plus 2. I need to remove that plus 2, so I need to subtract 2. But I need to subtract 2 from both sides of the equation. On the left side, 2t plus 2 minus 2 is reduced down to 2t. On the right side, negative 2 minus 2 is negative 4. We've now isolated the variable term. To eliminate that variable's coefficient, we need to do the opposite of what is being done. Currently I'm multiplying by 2, so to cancel that out, I need to divide that, and therefore both sides of the equation, by 2. 2t divided by 2 is t, and negative 4 divided by 2 is negative 2. It appears that the solution for this equation should be negative 2. Again, to check my work to confirm this actually is the solution, I will substitute negative 2 in for the t. So the equation on the left side had been 1/2 t, that'll become 1/2 times negative 2 plus 1/3. On the right side, it had been 1/6 t minus 1/3, so it becomes 1/6 times negative 2 minus 1/3. And again, in this check, we're trying to confirm that we do actually obtain a true statement. Here again is another example that I could do by hand, but I personally would choose to check this using my calculator. To check this, I will enter in 1 divided by 2 to give me 1/2, in parentheses, negative 2, plus 1/3, which I will type in as plus 1 divided by 3. And I can see that the calculator spits back negative 0.66666666, repeating until we hit that 7 at the end, which was just rounded. I recognize negative 0.666 repeating as the fraction negative 2/3. To finish the check, we now need to clear the previous work and type in the right side of the equation. 1/6, so 1 divided by 6, in parentheses, -2, minus 1 divided by 3, minus 1/3. Again, I recognize that we obtained the same value, -0.666 repeating. Since substituting -2 into both sides of the equation gave us a true statement, we have confirmed that -2 is the solution for this equation, and we can finish our work by giving our conclusion. The solution set is this set, -2.